Solving simultaneous linear equations. Learning intention. To learn how to solve simultaneous equations, including equations with two or more unknowns, and apply them to real-life problems. The linear equation y equals 2 over 3x minus 3 can be rearranged as follows. So we can multiply across by 3 to get 3y equals 2x minus 9, and then bring everything over to the left. So we'll have 2x minus 3y minus 9 is equal to 0. So this is the equation of the same line expressed in standard form. Standard form of the equation of a line is ax plus by plus c is equal to 0. This equation has two variables, x and y, for which there are many solutions. However, if we have two equations in x and y, they are either parallel with no point of intersection, or they intersect at a point, x1, y1, common to both lines. In this diagram, the lines 2x minus y plus 1 is equal to 0, so that's the red line, and 3x plus y minus 4 is equal to 0, so that's the black line, are plotted. They have a point of intersection at a, x, y, so there's our point of intersection there, and it's 3/5, 11/5, which satisfies both equations at the same time, i.e. simultaneously. We can solve two linear equations, i.e. find their point of intersection, by substitution, elimination, or graphically. Example 1, solve the equations 3x minus y equals 1 and 2x minus 2y equals minus 8. So we write down our equations. I'm going to multiply the second line by minus 3 so that I can eliminate the x's. So my second line becomes minus 3x plus 6y is equal to 24. My x's cancel. I'm left with 5y equals 25, so y is equal to 5. Then I pick one of the original equations, it doesn't matter which one. I replace the y with a set of brackets and put 5 into the brackets. And solving for x, I get 3x is equal to 6, so x is equal to 2. So the point of intersection of these two lines is 2, 5. I'm going to solve that again, but this time I'm going to use substitution. I'm going to take the second equation, x minus 2y equals minus 8, and I'm going to get the x on its own. Or I could have taken the first line and got the y on its own, because the y is already almost on its own. It's technically on its own, but it's a minus y, so we just would have had to change the signs. But the x is almost on its own. We just have to get rid of the minus 2y and bring it over the equal sign for the second equation. So it's easier and a little bit quicker to choose the second line. So I have x minus 2y is equal to minus 8, so I'm going to rearrange to make x the subject. So the minus 2y comes over and becomes positive 2y. So I have x is equal to 2y minus 8. So then I write out my other equation, and I'm going to sub x into the other equation. So that's my other equation, 3x minus y is equal to 1. I replace that x with a big set of brackets, and I put 2y minus 8 into the brackets. And then I multiply out my brackets. So 3 times 2y is 6y. 3 times minus 8 is minus 24. Minus y is equal to 1. 6y minus 1y is 5y. And 1 plus 24 is 25. And dividing across by 5, I get y is equal to 5. So I have y is equal to 5. I'm going to substitute that into one of the equations. I could go with the first one, the second one, or I could go with the one I have highlighted here in yellow, because the x is already on its own here. So it's just a quicker way of doing it. So I replace the y with a set of brackets, and I put 5 into the brackets. So I have 2 times 5 minus 8, which is 2. So x is equal to 2 and y is equal to 5 as before. Note 1. The technique for solving equations by substitution will be used later to find the point or points of intersection of a line and a curve. Note 2. Either variable can be substituted. Always choose the variable that is easiest to isolate. Example 2, solve the equations 2x minus 5y equals 9 and 3x plus 2y is equal to 4. So I write down my equations. I'm going to multiply the top line by 3. So I get 6x minus 15y equals 27. And I'm going to multiply the bottom line by minus 2. So I get minus 6x minus 4y equals minus 8. So now my x's will cancel. I can eliminate my x's. So I get minus 19y equals 19. So y is equal to minus 1. So I pick one of the equations and I'm going to sub in y equal to 1. So I'm going to go with 2x minus 5y equals 9. Replacing the y with a set of brackets and minus 1. I get 2x plus 5 is equal to 9. So 2x is equal to 9 minus 5. So 2x is equal to 4. And x is equal to 2. So the point of intersection of these two lines is 2, minus 1.